Welcome to week 3 of Design 330 in spring 2022. In week 3, we're really working with parametric design and how it can be used. And we're using the most simple part on this pump assembly. It's the transfer shaft. Now, in this assembly, the transfer shaft on the input drive will be one length. Between gears in different packs, it'll be another length. And on the output, it'll be another length. So we'd like to take care of that with something called parameters, where we can change this length easily and quickly and then develop the manufacturing file that's needed. And in addition, there's some differences between the size of the hex depending on what material it is, how it's being manufactured. So this becomes what's called a base file that is used to create many different variations of essentially the same thing. They're all exactly alike, but just a little bit different. So to do that, and I'm sure you're used to this already, of using parameters. I know that in Design 328 and 310, you use these extensively. We're going to do it in the most simple way. If you have more fancy ways, you can import from Excel files and things like that. But we've got a few different things to think about. A hex is made as a hexagram that's inscribed on a diameter. Let me show you what I mean by that. So the hexagram is inscribed on a diameter. And in this base file that you get, okay, it's 0.541 diameter and 0.469. Those are not the dimensions that are going to fit for this pump. They're just some dimensions that were drawn, and you'll have to figure out those dimensions. Now, this is the main dimension, and this is called a driven dimension, because a hexagon of 5 sides is fixed by the circular dimension. So that's really the one that you have to set to get the hex dimension that you want. And of course, we can recall from our gear that this hex has to fit in 0.541 across the flats. Okay, so D0 is the 0.541 or whatever you need it to be to work, and this D2 is the driven calculated dimension. And Inventor will figure that out for you. Okay, then there's the length, which you can figure out from the requirements that I gave you. We have no taper on this. There often you will see these with what's called a locking taper that will tap into place and lock. We are not doing that in here, and these fillet end radiuses are 0.03 inches. Okay, so that's the fillet radius, 0.03. And so variations of this, as you know, you can change those. Maybe I'll make it 0.75, and that gives me 0.650. So obviously that's too big to fit in my 0.541. And if I were to get it as close as I could, maybe 0.620, maybe 0.625. There it is right there. Okay, but we have tolerances to deal with, and I'm going to let you figure out what that dimension should be at the best. Okay, so this is a parametric drawing, and it's there for you. And that parametric drawing creates these views. Now, this is a little bit odd, the way I've got it set up. I could really do this a little bit better with a center mark all the way around. We don't even actually need that. We have the distance across the corners and the distance across the flats. And then we have a table. every time you make a new part number, you would have to list what D0, D1, and D2 and R1 would be. And the part numbers are different by what it's being used on, what material. So with this drawing, it's called a tabulated drawing. This figure itself can be used over and over and over and over again to just give you these numbers. So you can go back to your parameters to set the numbers and then export the file and just log the numbers right here. And of course, you're going to log them also in your parts list, that Excel sheet that you made last week. Okay, so that's the guts of what we're doing. You're going to do this for, now I'm going to give you the 3 dimensions, and it'll be here for you. Whoop, there we go. Well, I'm not going to give them to you, actually. Here, you're going to have to figure them out. But I'll write it down for you. One of them will have to extend 1 inch. The other one from the gear. The other one will extend 1.5 inches. And the third one will have to fit between the gears. And I'll tell you what that is. I'll tell you what that length is. So I'll give you those 3 lengths in an announcement. But that's the main thing. So you're going to work with your transfer shaft drawing and create a tabulated drawing that has many of these. Now I'm going to give you one other piece of information, is that depending on what this is made out of and how it's made, these design dimensions will have to be different to get your final part. So if there's a 3D printed part, it comes out 0.016 inches too big. So let's say I wanted this to be 0.541. If I 3D printed it from a model that was built 0.541, it would be bigger than that by 0.016. And that could cause me a problem. So I would have to actually shrink this dimension by 0.016 to make a 3D printed version of a set of parts. And I want to know that. So you're going to have regular versions that are made out of a metal that's very solid and very standard, and you can make it exactly to what you want to make it. And then you're going to make a 3D printed version that will be 0.016 smaller on D2. So you're going to have 1, 2, 3, an input, a transfer that's between 2 gears, and an output. And then you're going to have 3 more. So you have to know how to change this. Let me show you how to do that if you don't remember. I double click. And I think, and now I have to remember where it is. Insert row. Now I've got another row. Insert row. 1, 2, 3, 4, 5, 6. So that's how you insert rows. And then you can just click. Now you can type stuff in each of those. Now you're going to see that there's a tolerance problem. You're going to do a design review, collaborative with some colleagues, that will let you put in the tolerances that you want here. For the others, they're going to just be by the standard tolerance. I know I'm really putting a lot at you, but you can look at this over and over and over again. Sorry about that. Go. So what have we said? You're going to have one drawing for a whole bunch of parts. Input shaft, output shaft, transfer shaft. And then another 3. Actually, it's one drawing for all 3 of those. And then to include another 3 that are for the 3D printed STL files. Those all show up on here, and you just type in the numbers. But where do you get the numbers? You get the numbers by typing in the parameters as required. Okay, so that's the main idea of this week and this unit. There's still a lot of work there. You're really only going to create one drawing, but you're going to create a whole bunch of files, and you're going to create some other items too. So that's your start. That is your start.